All right. Not many people today. I think we will have a short meeting. Let's see. So I suspect that a bunch of people from core are trying to get this Alex size change over the fence because we have a couple of people that are really interested in getting it into master and then backported as well. So the gist of it is that we're using up extra space due to fragmentation, and people don't like it. So there was kind of a more extensive, bigger PR originally that was kind of complicated. So we went back to a much simpler PR that just set the BlueFS Alex size to 64K, and then a slightly more complicated PR in the end that Sage wrote that only uses a 64K Alex size on the shared device, but not on the DB or WAL device in BlueStore. So kind of the idea there is that we still have a large Alex size for RocksDB when we can, and then on the shared device we have a smaller one. That covers the first few PRs there. There is a fairly complicated PR for the OSD that implements async read for the replicated backend. I started kind of poking through that a little bit, but I didn't have time to really dig into it deeply. I'm hoping that we can get performance and profiling data on that because that's looks like a big change. Josh, I don't know if you've looked at that one at all yet or not, or Igor for that matter, if either of you guys have looked at it.
Don't think I have yet, no.
Okay. So, yep,
great.
that's... What was that?
Awesome, theoretically.
Yeah. Let's see, what else do we have here? There's a small optimization from Bajian Peng that for deferred IO notify and locking optimizations. He just noticed a couple things that we were doing. So he said there wasn't any significant performance improvement from it in his tests, but still, every little bit helps. Also, we've got a couple of finisher changes here, one from Igor that removes some lock acquisitions, and then also another one from Majian Peng that reduces unnecessary notify. So yeah, maybe both of those could improve things slightly. Let's see, in terms of stuff that merged, Eric had a small RGW PR, performance PR that merged. I don't think it actually had a huge effect if I remember right when I was asking last time, but again, every little bit helps. We've got a couple that have been updated. Niha's BlueFS Alex size PR, her original one, was worked on extensively this week, but I think that's probably not the one that will end up merging. Adam, your work, it looks like you've got some new updates. I imagine just chugging along still.
I am currently rebasing, and I'm going to, rebasing partly to go along with all of Kifu's mutex changes, and also going to do a little bit more rebasing to collapse some of the commits together and make it easier to review.
Sure. Very good. And
if you did want to review it, you would be more than welcome.
I would. I've got a pile of other stuff that I do too, as we all do, I'm afraid. But if I find myself with nothing to do, I will happily come and take a look at it. Unless you really need me to. If you do, I can try to make it work.
Not you in particular, just some people. I actually need to get Jason Dillerman and someone from the Ceph team, I think.
Yeah. That I think you're right. All right. Speaking of reviews, Josh, you've been reviewing Adam's sharding work. How's it looking? Other
Yeah,
Adam's
it's
sharding work.
looking quite good to me. It has it separates out different pieces of Bluestar and other metadata into different column families, like with the default settings of like 7 and for OMAP and 5 for I think maybe the allocator families. In addition to a few other column families for other pieces of metadata like the PG metadata.
Cool. Does it look theoretically possible like we're going to get this into Octopus?
Oh yeah, definitely.
Excellent. All right.
Yeah, it
That's very
required
good news.
a bit of more changes to the KD store interface than I had originally hoped, but it's relatively constrained in the changes to Blue Store itself.
Okay. Nice. That's fantastic. All right. What else we got here? Okay, no movement on a couple of different things. The multi-site sync fairness one from Eric. Nothing this week. So there's my original PR for the removing double caching, which if Adam's stuff looked like it was going to get punted until after Octopus, I was going to go back and just whip it into shape for Octopus. But now, if based on what Josh was just saying, if it sounds like charting's going to get in for Octopus, then Adam has a version of my PR that's rebased on top of his. So I'll go through and try to start reviewing that and see if we can get it all worked out so that we can get that in at the same time or soon after.
Yeah, it's worth noting there that part of Adam's PR is a addition to Blue Store tool to allow you to change the sharding strategy, either change the number of column families or making it not use column families anymore at all. It just takes a relatively short time to iterate through the whole database and do that, copy different column families.
Yeah.
Pretty nice, much better than backfilling.
Josh,
Yeah.
can you clarify the relationship of the PG log, PG info, and store and sharding? Is there always something isolated for that, or does it matter? Or
It doesn't particularly matter. In this case, so what Adam has so far puts the PG metadata in a single column family. We could look at sharding that out as well and see if it had any kind of impact.
I agree that we would like to keep it small as possible. I think that might be desirable.
Yeah, I think it might be worth experimenting with.
I don't know that we'd have theoretically for PG log, right? We shouldn't have very many keys in the database itself, right? I mean, optimally speaking, it would never go in. You just have like while buffer writes, and then you'd hit a tombstone before you ever flushed into level 0.
Well, I've heard this a lot, but I'd kind of like to build it so that it doesn't happen.
Yeah,
so if it does happen, that it's
yeah. So what NSPR does right now is it does put all the PG logs into a separate column family from everything else. So if they do end up going,
what's the
going down,
there?
The distinction is that they're different column families are separate L7 trees, so they have entirely separate storage and separate main memory buffers. So if you have a bunch of writes going to the PG log, you're not mixed in with a bunch of writes going to OMAP or object metadata, and are less likely to be flushed to disk spuriously.
So I guess what I'm wondering is, like, say you did split them across multiple column families, so now you've got like, a portion of your PG log entries going into one SST file or into one set, one level 0. So you'll never really get into like level 1 or level 2 because we don't have enough. And then you have other ones going into other ones. I wonder, is that actually a good thing with the way that the traffic works for PG log?
Why wouldn't it?
Yeah, I'm confused why it wouldn't be a good thing to keep it all in level 0.
No, I'm saying that
If it never goes there in the
with
first place, that's even
that's
better. But how is it harmed? How are we harmed by isolation? Isolation is usually good here.
the question in my mind is what advantage does it get you if you already don't have enough data to like require like a hierarchy because everything is landing in L0 anyway, then what does it buy you to actually split your to shard PG log across multiple column families? Because it does introduce other things, right? Like there's like I think some locking overhead that you end up dealing with, and potentially now you have um, multiple kind of compactions that happen less frequently for each one. I think.
Yeah, I'm not
I
sure
guess
that.
what I'm wondering is
I'm,
what's the
That's
point? Is what I'm
I'm
wondering.
not sure it needs to be sharded. I'm not sure there's enough data there, like you say, with that it would make sense to shard it. But just having it in a separate column family from everything else, just a single one is, I think, a good step.
Oh, yeah. Sorry, I wasn't disagreeing with that at all. I was just
Okay.
wondering why we would shard it. What if there'd be a benefit to
Yeah,
actually
yeah.
Well, that's
yeah.
fine. But yeah, but the isolation is the key. So if we already have it, if it's already ideal, where it's likely to be, we don't need to play with shorting it as well. So, but
Yeah, I guess worth looking at like what the size of it is, right? So if it's larger than we think, then maybe sharding it makes sense. If it's as small as we think, then a single column family is probably enough.
sounds same, but it sounds like,
Right.
but I think this is saying that this is getting most of the aspiration I have historically had. I have had an intuition that that isolation for this data set is really critical.
Yeah, absolutely.
We get it
And
already.
it actually provides a potential path for where there are kinds of isolation in the future. You can have different options for a given column family in RocksDB, so we could potentially be storing it in a different type of mechanism. Like
So I guess with that,
if
I mean,
later
usually
like BlobDB or something becomes
okay.
available, we could potentially use that for pglog.
I mean, do we have? I mean, the cases where this is really interesting is so it seemed to me. I mean, if we had any cases where when I assume that this is at least occasionally involved when we have some event that's like compassion or whatever on a RocksDB instance is in play and is causing ops to become opera tires to lengthen dramatically, and so I wanted to understand if we have any way to sort of see what the impact of this is on when an OSC is under extreme stress, or or larger, or for example, or perhaps when a long compaction is happening on the RxDB backing OMAP, for example, with large OMAPs present.
We with the isolation, we should definitely be able to start getting on what kind of writes we see going into like level 0. So that's really nice, right? We can see the flushing behavior there, um, and actually get like isolated stats, which is the one of the things that's been irritating so far.
Yeah, that's a good point. We should be able to get much better visibility into what RocksDB is doing for different LSM trees or different kinds of data here.
One thing that we can do too that'd be really nice is even if we do have a bunch of that data, the PG log data ending up in the level 0 or whatever, we could kind of extend that PR I have to avoid the double caching of O nodes to also make it so that we don't assign a cache or we assign a very small cache for specifically for PG log.
Yes, that's an excellent point.
We never read it, right? So, or if we do, it's not really important that it's cached. We read it like once, right?
Yeah, I can definitely see us wanting to play around with some of the per column family options there in the future.
Yeah. So yeah, that's exciting. That's really good. All right. What else do we have here? I think there's still just kind of general work going on with the MDS and MON memory limit. So those are chugging along. think Igor and Adam still have some stuff out there for automating moving RocksDB files between BlueFS devices. I don't know if Adam is working on that at the moment. He might be working on his other stuff. I have not gone back and reviewed the IOU ring or the Messenger IOPS PR from Roman, so that's on my list. And as is redoing my op tracker PR that we decided we wanted to kind of change around a little bit. Oh, and then the cache binning rebase. So I think that we probably want to do that after the O-node, double O-node caching PR, but it's not really reliant on it. So maybe I'll try to quick get that in now, so there's less to do before Octopus, if we want to actually merge that or not. So maybe that's next on my list. Yeah, I think otherwise a lot of these other ones are kind of old. All right. So the only thing I have here for discussion topics is to kind of mention, well, I guess we already talked a little bit about it, but BlueFS Alex size and what we're doing there. The gist of it right now is to set the Debian wall Alex size large, and then for shared devices have it be smaller. I think 64K is kind of what we're talking about now, which would be the same as the min Alex size on hard disks, and then not big enough so it doesn't have a huge performance impact, probably no performance impact really on NVMe drives. So that's kind of the current plan on that. But Igor, since you're here, maybe the more interesting discussion for this week would be to talk about 4K min Alex size.
Well, yeah, that's an interesting question, but actually I don't have any actual information to discuss at the moment.
I have some. In the Etherpad, there's a link to a Google Doc. If folks want to see it, I'll paste it. I'll put it in the chat window here. So I'm actually still creating the graphs, I guess, but some of the numbers are in there. The gist of it is that at least on Inserta, compared to a couple of years ago, 4K min Alex size is not looking too bad. Okay, make sure I've got these right.
Which tab should we look at?
So I've got data for OMAP writes, 4K OMAP writes with Rados Bench. So let's, I guess, look at that one first. And this is looking at BlueFS Alex size at 1632 and the default 1 meg sizes, and then the 16K min Alex size versus 4K min Alex size. And kind of the gist of it is that, at least for pure OMAP writes, it actually was faster at a 4K min Alex size than it was at a 16K min Alex size. And so I'm not exactly sure with OMAP why that would be the case. But that's what I saw. So I guess, that was kind of the first indication. If I move over to 4K object writes,
I guess with OMAP, you are allocating only like a object info and nothing on lay on disk, the data portion.
Hmm.
Hmm.
So why would you think there would be a difference in performance there?
No, I don't see any reason. Never mind.
That's kind of where I was at too. I was like, that's interesting. All right, there's a bunch of other random stuff in here, but let's actually just go to the last tab, the RBD iteration test, because that's the one that's kind of the most, um, especially at the 128K IO size. So if you look at that, for like 4K RBD IOs, it's all really pretty close. For reads, it looks like we're a little slower with a 4K min-alloc size, but in fact for writes, it's actually doing slightly better. And the difference there, right, is that it kind of makes sense, right? Because with 4K you have more data, more metadata in the database, and potentially more work to do for reads and for writes. But it also means that for these 4K IOs, you have less write-ahead log data being written out. So that's kind of the trade-off, right? So for writes, it is, in this case, a little bit faster. For reads, it's a little slower. What I found incredibly interesting, though, was what's going on here with the 128K writes, specifically sequential writes. And it's significantly faster. In some cases, oh wait, yeah, in this like iteration 3 test, it was significantly faster. I guess not for iteration 2, but for 1 it was. Anyway, there's crazy stuff going on there. The initial write is significantly slower than subsequent iterations, and this is with a prefilled volume, although the objects were prefilled at a 4 megabyte IO size. So in any event here, there's crazy stuff going on. So it's probably worth some time investigating what it is that's going on here. Having said that, it's not clearly worse using a 4K min-alloc size. With 4 megabyte writes, I think I didn't get the graphs written out here, but I think it was a little faster in some cases for writes and a little slower in some cases. Yeah, for reads again, just looking at the raw numbers. So in any event, it's not clearly significantly worse. And that's kind of what our criteria was when we set it back to 16K ages ago, was that it was back then. So the benefit, right, is that by setting a 4K min-alloc size, we don't, for small RGW objects, we won't have the kind of crazy space amplification that we do now. Instead of using 16K for a 4K object, we'd use 4K. So I guess that's what I've seen so far. Igor, I'll be very curious to see what you see with your testing that you're doing as well. If it matches what I'm seeing or it's different.
Okay, I will share once I have it.
And Igor, you were saying that you were thinking about resurrecting your PR to place small objects in RocksDB itself?
Yeah. There was a PR, well, maybe half a year ago, which tries to keep very small objects. I tried against 1K and 2K, as far as I remember, to keep these objects in KV store. And actually it showed better performance than keeping them on the main device. Not to say about space sizing we are getting this way. Well, maybe I wasn't 100% correct, because I was using DB at NVMe drive. Well, I was using both NVMe for both DB and main device that time. And actually now I'd like to check how this stuff behaves on spinners. if we have both DB and well, actually, we need different scenarios to test here, and that was the main comment from Sage that time. But yeah, so I'd like to check different block size, different object sizes, different backend drives, and things like that.
Did you run any tests with very large amounts of objects so that the database grew to like the size of the disk?
Unfortunately, no. The testing was pretty limited at that time. So,
Okay.
and now I'd like to.
Yeah, I'd be concerned about the larger database sizes. I mean, charting will certainly help there, but I'd be a little bit cautious about putting more things into RocksDB if we can avoid it.
Well, at least for cases when we have just a single drive for user data and for DB, this concern might not be very significant because, well, we use space either for database or for main device. But well, anyway, we
Yeah, we'll see. I'm more concerned not just about space usage, but about the behavior of RocksDB and potential for even long compactions from that larger amount of data in there.
Josh,
Yeah.
I'm also worried about space though, with the amount of just potentially
Space amplification.
things short. Well, yeah, I mean, depending on how many levels deep, I guess you go, you can end up with stuff in, ending up in both like level 0 and level 1 and level 2 in some situations, I think.
Mm-hmm.
So you're probably right though that like write amp is maybe the bigger concern, but the space amp could still be an issue. Well, anyway, yeah, testing will help, right?
yeah.
Certainly.
All right. I added the 4 megabyte graphs here to this chart, but yeah, it's interesting how it's slower for multiple iterations for the large writes, which can make sense as it fragments. But then for these 128K writes, it's actually faster on the subsequent iterations. Well, anyway, definitely some interesting stuff on the right path there to look at. Well, that's all I've got, guys. So anything anyone else wants to bring up this week? All right. Well, then I think next week we are going to get Sam to come and present his latency analysis work that he's been doing in BlueStore. I'm not totally positive on that, but he's out at the Flash Memory Summit this week, so he wasn't able to do it today. But hopefully next week we'll get him. So I guess that's it. Have a good week, guys.
Thanks, you too.
Thank you. Bye.